Now, please look at this trick in this approach. It is a very, very good approach. We will see this here. What we do, the same equation, I will change it by linear transformations using elementary linear transformations. I convert A matrix A to an upper triangular matrix or lower triangular matrix. Doing upper triangular matrix is much more common. So what we do is we make, by elementary row transformations, we make these to be zeros. You know, this coefficient to be 0. So this term goes. Then this and this coefficient to be 0. Okay. And then we do this transformation. After that, these coefficients change naturally. This transformation is very easy. Okay, in 2 steps we will get this transformation, because in this transformation we don't have to worry about making 1 0 0 0 1 0 0 0 0 0 0 1. We don't have to worry about converting it into an identity. What we are doing is, only in matrix A we are making 3 elements zeros: A21, A31 and A32, using elementary row transformations. That's it. And once we make 0, then we get x3. X3 will be B3 dash by A33 dash. We found x3. Okay. Once we find x3 from equation 3, third equation, then we do what is called as back substitution. Now, back substitution, I find back substitution in, this is from equation 3. I will modify this. 1 2 3 become 4 5 6. So from equation 6 I get x3. Now back substitution in equation 5. Once I get x3, I'll substitute that value in equation 5. Then x2 I get as minus A23 x3 plus B2 dash divided by A22 x1, A22 dash. So I get x2. Okay, this is back substitution. I get x2, and again we do a back substitution in 4 to get x1. I'll substitute x2 and x3. So x1 will be bring this to the other side, minus A12 dash x2 minus A13 dash x3 plus B1 dash. All right, divided by A11 dash. So by this you solve for x1, x2, x3, and this method is the most popularly used method in solving the differential equation. Okay. Differential equation, solving the system of linear equations. This method, for numerical methods, this method is the method that is used, not the Gauss-Jordan method. Gauss-Jordan method involves a lot many more calculations. So the same problem that we did for Gauss-Jordan method, the same problem we'll do using Gauss elimination method. Yes, in Gauss-Jordan, we convert the matrix A to identity matrix 1 0 0 0 1 0 0 0 1. However, in Gauss elimination method, we convert it to an upper triangular matrix. We can convert it to a lower triangular matrix also. If we convert it to lower triangular matrix, we first find x1. Then once we find x1, then we find x2. And then we find x3. That is called as the forward substitution method. This is back substitution. From the lowest equation, we keep back substituting to find the original. If we transform it to a lower triangular matrix, we'll have to do forward substitution. There are two methods to it. So now let us solve this. The same problem using Gauss elimination method. In the first step, we need to make these two zeros. These two elements, A21, A31. Second row, first column, third row, first column, using the first one. So one method, of course, I said straight away in the beginning, that do this transformation R1 as 1 by 3 R1. This will make it easy to eliminate 1 4 by 3 5 by 3 6 13 20 2 minus 1 8 5 minus 2 7. Now R2 as R2 minus 2 R1, R3 as R3 minus 5 R1. Remember, in the first step of elimination, in this transformation, if we have to eliminate in the first column the second two elements, then the first row has to be used. R1 has to be used to be R1 has to be subtracted or added to those given second and third rows to achieve our desired objective. So let us do this transformation. So this is 1 4 by 3 5 by 3 6 here. Now let us do this transformation. R2 is R2 minus 2 R1, so this becomes 0. So 1 minus 2 times 4 by 3. So 1 minus 1 minus 1 minus 2 times 4 by 3. So minus 11 upon 3. Minus 11 upon 3. And this one will be 8 minus 10 by 3. 14 upon 3. This is 0. In the third row, the second term, the first element is 0. The second element is minus 2 minus 5 into 4 upon 3. So minus 26 upon 3. Minus 26 upon 3. Next is the last one, 7 minus 25 upon 3. So minus 4 upon 3. Now the second row here transforms to 13 minus 2 R1. 13 minus 12, you will get 1. And then 20 minus 5 R1. So 20 minus 5 into 6, 30. So minus 10. Okay. So one more step to do. Just one more step. Okay. So do this. R2. You multiply by minus 3 by 11. R2. And R3, let us multiply only with 3 and see. Okay. Later we will do the change. We just want to simplify our calculations. So 1, 4 by 3, 5 by 3, 0, 1, minus 14 by 11. Okay. This is 6 minus 3 by 11. And the last one multiplied by 3, minus 26, minus 4, minus 30. So now what we need to do is eliminate. Don't worry about the first row, just eliminate this minus 26 by elementary row operations, make it 0. So we get R3 as R3 plus 26 R2. That's it. This becomes 0. So 1, 4 by 3, 5 by 3. X, Y, Z. 6 minus 3 upon 11. Okay, R3 will change, so I cannot write this one. R2 remains as it is, 0, 1, minus 14 by 11. Then here we get 0, minus 26 plus 26, 0. Then minus 4 plus 26 into minus 14 by 11. Minus 4 plus 26 into minus 14 by 11. So what we get is minus 44 minus 384, 364, I think. We did that. You get 408 by 11. And here also we get minus 30 minus 26 into 3 by 11. So minus 330 minus 78 by 11. So again you get minus 408 upon 11. So problem simplifies very quickly. So I'm erasing all these calculations. So this implies we divide R3 by 408 upon 11. So you get this 1, 4 by 3, 5 by 3, 0, 1, minus 14 by 11, 0, 0, 1, X, Y, Z, 6 minus 3 by minus 3 upon 11, 1. So very clearly you can see, you take the last row, consider row 3. So we get from row 3, we get Z is equal to 1. Substitute in row 2. So row 2, when you multiply this row 2 with X, Y, Z, you get Y minus 14 by 11 times Z is equal to minus 3 upon 11. So what we get is, substitute Z equal to 1. We get Y is 14 by 11 times 1 minus 3 by 11. 14 by 11 times 1 minus 3 by 11. So you get 11 upon 11, which is 1. So Z equal to 1, Y equal to 1. Now substitute Z equal to 1 and Y equal to 1 in row 1. So X plus 4 by 3, Y plus 5 by 3, Z is equal to 6. So X is 6 minus 4 by 3 times 1 minus 5 by 3 times 1. So 6 minus 4 minus 5 is 9. So 9 by 3 is 3. 6 minus 3 is 3. Therefore, X equal to 3, Y equal to 1, Z equal to 1. This was the same result we got using Gauss-Jordan. And this is by Gauss elimination.